continue where we left off last time, which will be basically finishing this example. So let's just remind ourselves what we were doing. So let's make this a little bit bigger. So we wanted to find the vector function which describes the intersection of these two surfaces, right? So this is the intersection of these two surfaces, and I want to find the vector function which represents this. So actually this would be something like this. So this would be a vector going around this intersection, and I want to do that. This was the last example I was going to do in this lecture before we were interrupted by the video went off. So let me finish this and then we'll just continue with the next lecture. Okay, so so let's see. Well, I mean, first this equation of the circle, of the cylinder, is x squared plus y squared is equal to 1. We could write it this way, right? We can say that x is equal to cosine t because this is the unit circle, right? So this is the unit circle on xy plane. So we can write it x equal to cosine t, y is equal to sine of t. Yes? And, well, I mean, here t goes from 0 to 2 pi. All right. What about so let's just keep this in mind. What about the equation of that plane that we are given? Well, so let's see if we can write that also in some kind of a parametric way. So I mean, we had x plus y, x plus z, right? So we had x plus z is equal to 2. So actually it was y plus z. So let me just clean this up. So this was actually y plus z is equal to 2. And so from this we get that z is equal to 2 minus y. Yes. And we can, since above we had y is equal to sine of t, I could write this as 2 minus sine of t. Okay, so z is equal to 2 minus sine of t. Well, let's think a little bit about this now. Okay, so the equation of the curve C, so equation of the intersection C now is given this way. X is equal to cosine t, y is equal to sine t, and z we said was equal to 2 minus sine t. Yes, and so in vectorial, as a vector function, this can be written this way: r of t is equal to cosine t times the vector I plus sine t times the vector j plus 2 minus sine t times the vector k. And basically that's what it is, right? All right. So we gave a parametrization now of precisely this intersection curve that we have. Remember, we had that intersection curve and we had that cylinder going there. And so this intersection is the curve C that we just described as a vector function. All right, and as a space curve. Okay, so that will actually conclude this section. Basically, that's all I was going to do in this section. There are actually actually many problems that one can do there. We would stop here. I will continue with the next section, also on video. I will prepare it beforehand, and we will discuss it during regular lecture time. So thank you very much for your attention, and I will just stop here. Thank you.